Have you ever wondered how quickly a viral video spreads, or how your savings grow with compound interest? The answer lies in geometric sequences. What if you could predict exactly how many views your video will have in a week, or how much money you'll have in your account after 10 years? This video will teach you the simple formula to make these kinds of predictions using geometric sequences. A geometric sequence is a list of numbers where each term is multiplied by a constant value to get the next term. This constant multiplier creates a predictable pattern that we can use to find any term in the sequence. Each number in the sequence is called a term, and the constant multiplier is called the common ratio. These are the two fundamental components of every geometric sequence. Here's a simple example: 2, 4, 8, 16, and so on. Notice how each term is exactly double the previous term. The pattern becomes clear when we see that we multiply by 2 to get from one term to the next. 2 times 2 equals 4, 4 times 2 equals 8, and 8 times 2 equals 16. In this sequence, our first term is 2, and our common ratio is also 2. The common ratio tells us what we multiply each term by to get the next term in the sequence. Now that we understand what geometric sequences are, we need a formula to find any term in the sequence without having to calculate all the previous terms. This is where the nth term formula becomes incredibly powerful. This formula has 4 key components, and understanding each one is crucial. Let me break down what each variable represents in this formula. But why does this formula work? The key insight is understanding how geometric sequences are built. We start with the first term, and then we multiply by the common ratio repeatedly to get each subsequent term. Notice the pattern here. To get the second term, we multiply a1 by r once. To get the third term, we multiply a1 by r twice. To get the fourth term, we multiply a1 by r 3 times. Do you see the pattern? Exactly. To get the nth term, we multiply a1 by r exactly n minus 1 times. This is why the exponent in our formula is n minus 1, not just n. We've already started with the first term, so we only need n minus 1 additional multiplications. Now let me show you how to apply this formula with a simple example. Consider the sequence 2, 6, 18, 54, and so on. Here, our first term a1 equals 2, and our common ratio r equals 3. If we want to find the fifth term, we substitute these values into our formula. So a5 equals 2 times 3 to the power of 5 minus 1, which is 2 times 3 to the fourth power. 3 to the fourth equals 81, so we get 2 times 81, which equals 162. This is our fifth term. This formula is incredibly powerful because it allows us to find any term in a geometric sequence directly without having to calculate all the terms that come before it. In our next examples, we'll practice using this formula with different types of problems. Now let's work through our second example, which involves a fractional common ratio. This type of geometric sequence behaves quite differently from sequences with whole number ratios. Here we have the sequence: 16, 8, 4, 2, and so on. Notice how each term is getting smaller. This is because we're multiplying by a fraction each time. Our goal is to find the fifth term, a sub 5. Let me highlight this to make it clear what we're looking for. Now let's solve this step by step using our nth term formula. I'll clear the screen and work through each step methodically. Step 1. First, we need to identify our first term, a sub 1. Looking at our sequence, the first term is clearly 16. Step 2. Next, we need to find the common ratio r. Remember, we find this by dividing any term by the previous term. Let's use the second term divided by the first term. When we divide 8 by 16, we get 1/2. This fraction tells us that each term is half the size of the previous term. Step 3. Now we can substitute our values into the nth term formula. We have a sub 1 equals 16, r equals 1/2, and n equals 5. Step 4. Let's simplify the exponent first. We have 5 minus 1, which equals 4. So we need to calculate 1/2 to the fourth power. Step 5. Now we need to calculate 1/2 to the fourth power. This means 1/2 times 1/2 times 1/2 times 1/2, which equals 1 over 16. Finally, we multiply 16 by 1 over 16. Notice that 16 times 1 over 16 equals 1, because 16 and 16 cancel out. Therefore, the fifth term of our geometric sequence is 1. Let me highlight this final answer. This is a perfect example of exponential decay. Notice how the terms get smaller and smaller: 16, 8, 4, 2, 1. This happens because our common ratio is a fraction between 0 and 1. When we multiply by a fraction repeatedly, the values decrease towards 0. Now for our third and most challenging example, we'll work with a geometric sequence that has a negative common ratio. This creates an interesting alternating pattern that we need to handle carefully. Here's our problem. Find the sixth term of the geometric sequence that begins with the following terms. Notice how this sequence alternates between positive and negative values. Positive 2, negative 6, positive 18, negative 54, and so on. This alternating pattern is the key characteristic of a geometric sequence with a negative common ratio. We need to find the sixth term of this sequence, which we'll call a sub-6. Now let's solve this step by step. First, we need to identify our first term and calculate the common ratio. Step 1, we identify the first term. Looking at our sequence, the first term, a sub 1, equals 2. Step 2, now we calculate the common ratio by dividing any term by the previous term. We calculate r equals a sub 2 divided by a sub 1, which is negative 6 divided by 2, giving us negative 3. Notice that our common ratio is negative 3. This negative ratio is exactly what causes the terms to alternate between positive and negative values. Now let's apply the nth term formula to find the sixth term. Step 3, we apply the nth term formula. Remember, a sub n equals a sub 1 times r to the power of n minus 1. For the sixth term, we substitute our values. A sub 6 equals 2 times negative 3 to the power of 6 minus 1. First, we simplify the exponent. 6 minus 1 equals 5, so we have 2 times negative 3 to the fifth power. Now we need to calculate negative 3 to the fifth power. Since we're multiplying an odd number of negative factors, the result will be negative. Negative 3 to the fifth power equals negative 243. Now we can complete our calculation. Step 4. For our final calculation, a sub 6 equals 2 times negative 243. Therefore, a sub 6 equals negative 486. Looking at our complete sequence, we can see the alternating pattern continues. 2, negative 6, 18, negative 54, 162, and finally negative 486. Here's the key insight about negative ratios. They create alternating positive and negative terms. Remember that odd powers of negative numbers give negative results, while even powers give positive results. This is why our sixth term is negative. We raised negative 3 to the fifth power, which is odd. This alternating pattern is a crucial characteristic of geometric sequences with negative common ratios, and understanding it will help you solve similar problems with confidence. Before we wrap up, let's address some common mistakes students make when working with geometric sequences, and I'll share some helpful tips to avoid them. The first common mistake is forgetting the order of operations when using the nth term formula. Students often multiply the first term and common ratio together before calculating the exponent. This is incorrect and leads to wrong answers. Remember, always calculate the exponent first, then multiply by the first term. The correct answer is 162, not 1296. The second common mistake is miscalculating the common ratio, especially when dealing with negative numbers or fractions. Students sometimes get confused about which term to divide by which, especially with negative ratios. Always divide the second term by the first term, and double-check by verifying the ratio is consistent throughout the sequence. Here are 3 essential tips to help you avoid these mistakes and solve geometric sequence problems correctly every time. Following these simple guidelines will help you master geometric sequences and avoid the most common pitfalls that trip up students. Congratulations! You've successfully mastered finding the nth term of geometric sequences. This is a powerful tool that will serve you well in advanced mathematics and real-world applications. In this video, you learned how to use the formula a sub n equals a sub 1 times r to the power of n minus 1 to find any term in a geometric sequence. You discovered how to work with different types of common ratios, including whole numbers, fractions, and negative values. You also practiced step-by-step problem-solving techniques and learned about common mistakes to avoid. These skills will help you tackle more complex sequence problems with confidence. If you found this video helpful, please give it a thumbs up and subscribe for more mathematics tutorials. I'd love to hear from you in the comments. Let me know what topics you'd like to see next, or if you have any questions about geometric sequences. Ready to take your sequence knowledge to the next level? Check out our next video on geometric series and their real-world applications, where you'll learn how to find the sum of geometric sequences and see how they're used in finance, science, and technology. Thank you for watching, and I'll see you in the next video. Keep practicing, and remember, mathematics is all about building one concept upon another. You're doing great.